In this lesson, we're going to be using the easiest possible means to set up a RAG system just to get up and running. So we're not going to worry about chunking or embeddings or anything complex. And let's not even worry about an automation platform. So let's just demonstrate what RAG can actually do. There are lots of different RAG style web apps that you can use. And from my experience, NotebookLM is absolutely one of the best. So you just go to notebooklm.google.com, and once you sign in, you land on this page and then you just click create new notebook. And this is the RAG aspect of it here. You need to add sources because this chatbot within NotebookLM is going to be grounded in the data that you provided. So let's upload some files to test this out. And you may have seen a McLaren Formula One car in the background here. Let's use the Formula One regulations to test this out. So let's grab a couple of documents and upload them to NotebookLM, and then we can chat to these documents. So this one is the technical regulations, these are the financial regulations, and these are the sporting regulations. So let's start there. So those have all downloaded. And if I just drag them in here, there's the first one and there's another. So there's 3 documents. Then it takes a while to process them. So what's happening in the background here is it's actually breaking down these documents, embedding them in a vector database, so that we can actually have a conversation with them in this chat interface here. And you can see at the bottom it says 3 sources. So if we ask a question, what is the plank assembly, which is a part of an F1 car, it's then able to provide an accurate answer based off the sources that you uploaded. So based on the sources, it's a key component fitted below the central surfaces of the floor body. So you have lots of these citations. So number 1 is referring to the technical regulations, and this is the chunk that was actually indexed. And if you keep going down, you can see number 2, still the technical regulations. Down here, number 11 is a different section of the technical regulations. So you get the idea. It's fully grounded in the documents. If I ask a different question now, what's the weather like in New York? It's going to look into those documents and it's not going to find anything that's of relevance. Based on the sources provided and our conversation history, there's no information about the weather in New York. And then it explains what the documents are about. So that's what's great. And if you ask another question, which is semi-related, what size tire is fitted on an Audi A4, and you're getting back an accurate answer based on the sources provided, there is no information regarding the tire size. So the LLM isn't going into its training data to actually figure that out, because the LLM is most likely trained on a huge corpus of information, and it probably does have a good idea of what tire size fits on an Audi A4, but it's not actually speculating. It's not using that training data. It's only based on the information that's in context via these sources. That's what RAG is. So as of the time of recording this, there is no API to use NotebookLM because it has a really good RAG engine built into it. If you want to use RAG for your AI agents or AI workflows, then you'll need to find another solution. So the most basic way to get this type of functionality in your AI agents or workflows is to use the likes of OpenAI's Vector Store, and that's what we'll do now. So if you go to the playground of OpenAI, which I'll link below, and if you click on Dashboard and then Assistants, you can create a similar assistant to what we just did in NotebookLM, except this time you can actually programmatically interact with this via an AI automation platform like N8N or Make.com. So if you click Create on the top right, and we'll call this one our F1 Advisor, give it some system instructions. You are an F1 expert. You are tasked with answering a question using the provided information, and we're going to upload those documents. Your goal is to provide an accurate answer based on this information. If you cannot answer the question using the provided information, say, sorry, I don't know. This piece is absolutely crucial because if you don't put this in, it's going to fall back on its training data and it'll speculate answers. And this is where hallucinations kick in. So if we click Save to that, so on the right-hand side here, enable file search, and then click Add Files. And here you're going to drag in those files. So we'll do the same thing that we did last time. So on the bottom right, click Attach, and then that creates a vector store for this F1 Advisor Assistant, and it uploads those 3 files to it. At this point now, we have our agent that we've provided instructions. We can specify a model. Let's go with GPT 4.1. We've uploaded files to a vector store that's attached to the assistant. And then on the bottom here for temperature, let's decrease this to something like 0.4. And the reason for this is the lower the temperature is, the less random it becomes and the more deterministic it becomes, which is what you want in a RAG agent. You don't want it speculating or getting creative. Okay, so then that's all set up. Click on Playground then, and that brings you into this assistant in the playground, similar again to what we did with NotebookLM, and now we can ask questions. What is the plank assembly? Plank assembly is the component in F1's car, often referred to as just the plank. Now you'll see that that's a lot less of a detailed answer than what we got from NotebookLM. And this may be down to a number of things. It could be the number of chunks that were returned from the vector store. It could be different LLMs that are trained behind the scenes. And that's a lot of what we get into with RAG, is fleshing out what's happening behind the scenes to get to the right type of outcome. So let's now ask an irrelevant question. What is the current weather in New York? And you get, sorry, I don't know. Perfect, so it's not speculating. So now let's ask our Audi A4 tire size question, because this is somewhat related in the sense that it's a car and these are motorsport regulations. And it comes back with, sorry, I don't know, which is ideal. So this is our RAG agent now set up. There is a bit of a lack of transparency in the sense that we can't see the chunks that were retrieved to help generate this text, nor do we have citations, but at least we are getting a response that's somewhat accurate. So now to bring this into an automation platform, if you are brand new to N8N, then to quickly get started with this masterclass, I do recommend signing up to a cloud account on their platform. And then once you become familiar with N8N, you could self-host it locally or on cloud infrastructure like Railway or Alestio. And if you are following along with the build, I do recommend pausing the video regularly so you can make sure your configuration is aligned to what I have in the video. If we go to N8N and let's just kick off workflow, so we'll just trigger it manually and then type in OpenAI, and then we're going to message an assistant, as you can see there. And from here then we can choose the assistant or F1 advisor. And for memory, let's set it to thread ID. And we're getting an error actually. So instead, let's just use the memory connector and we'll manage the memory on the N8N side. So we'll save that. And now you can see memory here. So if you just click that and just use simple memory, and let's set the context window length to say 20. So we'll remember the 20 most recent exchanges within this conversation. The longer you set the memory, the more expensive it gets because there's more information and context, and sometimes it can kind of pollute the accuracy of the responses as well. So we'll leave it at 20. So we'll save that, and let's go again, repost the message. So it's gone off to the assistant, and now you can see the response. And that's a similar response to what we were getting in OpenAI's Playground. The plank assembly is fitted to the underside of the car. And then the question of what's the weather in New York, we're getting back, sorry, I don't know, which is ideal. So that's definitely the simplest way to set up a RAG system in N8N, where you can just drag and drop files and you don't need to worry about chunking or embedding. The OpenAI Assistant is a type of agent in the sense that you have memory, it has knowledge because we've uploaded files, and you can also add tools. So there's function calling or tool calling. It is still in beta though, and it's soon to be replaced by the Responses API within OpenAI. So it's not really used that much within N8N. So while it is pretty easy to get a basic RAG system set up, simply by creating an assistant and dropping in some files, and then just dropping in this node here, and then you have a conversation with it, it does have a lot of shortcomings. And the best way to kind of explain this is, if I ask this question here of what aero elements are on the back wing, you'll see that this is going to the assistant, it's going to look into the files in the vector store, and it's not going to find any good matches. And it's going to return with, sorry, I don't know. Whereas if I ask that same question in NotebookLM, I'm getting back a much more thorough answer. And the key reason is this first sentence. Based on the sources provided, the back wing is referred to as the rear wing in the regulations. So NotebookLM was able to actually infer back wing equals rear wing and was able to search the vector store either for that term or it has a more sophisticated means of retrieving data. So this does point to limitations within the OpenAI's vector store approach. I'd recommend that you set this up yourself, create an assistant in the playground, upload some files, and then in N8N, create a quick workflow to hit that assistant and ask it some questions on the data. And what you'll find is it answers really well for certain types of questions, whereas for other types of questions, it may say it doesn't know, like we have here. It may hallucinate an answer, or it may give incomplete answers.